Hello, welcome friends to Engineering Simulation Club. Here we will simulate a simple capacitive resistive network to demonstrate its time constant. This is that circuit. Here we will use the changeover switch so that at one position it will get charged and at other position it will get discharged, and first position will be obviously charging position, and it will be charged and get discharged through this common resistance R. This is capacitor C, this is changeover switch, and this is supply voltage. We will consider some values. R equal to 10k and C equal to 100 microfarad. So higher is the resistance, it will take more time to charge, hence we are calling its RC time constant is high. Similarly, higher is the capacitance, it will take the time to charge more. So RC time constant tau, it is defined as tau equal to R into C equal to 10 into 10 to the power 3 as 10k into 100 into 10 to the power minus 6 being a microfarad. So it will be 1 second. Okay, what is mean by this time constant we will see just now. The first thing, we have calculated the time constant, and for the voltage across the capacitor while charging equal to V while charging equal to supply voltage Vs into 1 minus e to the power t by tau. It is a function of time. Okay, so as time increases, the voltage on this capacitor goes on increasing. Similarly, and for discharge, V discharge equal to, that is during the discharge, voltage across the capacitor will be Vc, whatever the voltage available on the capacitor at t equal to 0 multiplied by e to the power minus t by tau. Okay, so in one time constant, that is t equal to 1 second, and tau equal to also 1 second, our charge will be Vc, charging Vc equal to, let this be the 10 volt multiplied by 1 minus e to the power minus 1 upon tau also 1 else. So it will be, it comes to 6.32 volt. It get charged up to, or we may say 63.2% of the supply voltage. 63.2% of the supply voltage. Similarly, we discharge equal to 10 at the end of sufficiently long duration, that is nearly 5 times the time constant, it will get, we can consider it is get charged fully, and so it is the 10 volt will be the initial voltage on this capacitor, and it will be 10 multiplied by e to the power t by tau equal to 3.68 volts, or we can say 36.8% of the voltage. So if we are connecting some oscilloscope here and observe the graph of voltage across the capacitor, what we will get? We will get such type of graph. It will start initially fully charged, it will, and again it will get fully discharged up to 0. Okay, so we are parameterizing R as 10K and C as 100 microfarad, and we are getting time constant as 1 second. So to charge it up to 100%, that is 10 volt, we will require 5 seconds. It will be 5 seconds, and after 1 second the voltage will be 6.32 volt, and after 6 seconds, that is 1 second after the discharge start, we will start the discharge after 5 seconds, and after charging the after starting the discharge, it will take 1 second, that is 6 seconds, it will drop down to 36.8%, that is 3.68%. It is interesting to note down this plus this equal to 10. 0, 0, 6 plus 3, 10. Okay. Now we will run the actual simulation. Thank you.